Hello, hello, hello. I hope you can hear me. I hope you can see me, this time in a different environment. Hopefully I'm hearable. Hopefully you can see me. Today's topic is Amazon MSK, so managed streaming for Kafka. Managed Apache Kafka on AWS. Very interesting topic. Very, very interesting one. So give me a shout out on the chat if you are hearing me well, and we will start in a 1 minute. Here's a recap what we did last time. So it's the 6th episode. We covered SNS, SQS, MQ, Kinesis data streams, Amazon Event Bridge, and today is time for managed Apache Kafka. We have 4 episodes that are currently scheduled on the channel, so you can set reminders on the YouTube. And if you have any questions, open topics regarding those services, feel free to reach me out either on LinkedIn or on GitHub or somewhere else on the Slack channels. I will be happy to cover all of those in the following streams. So we are a little bit after the middle of the whole series, and we are ending the series around 8th of September, if I recall correctly. So as you may imagine, in 4 weeks. So it will be a pretty interesting ending, especially that at the end we've got Kinesis video streams with particular emphasis on the signaling channels. And those are pretty interesting, especially for people that are currently doing with WebRTC. Okay, so without further ado, let's go with our goals. Once again, it's a live streaming format, so I count on your active participation. It's also a deep dive into AWS messaging, so we are trying to provide you as much information as we can. I would like to highlight proper use cases and differences between those services. And last but not least, I challenge myself to teach you about things that you didn't know existed in the first place regarding this particular service. Kafka is a pretty new thing. Managed streaming for Kafka. It's a pretty new thing on AWS. So it will be pretty interesting to hear if you have any experiences so far with this service. Let's dive into. This is the full name of the service. MSK is just an acronym. They are skipping Apache in order to have the nice acronym. So it's a fully managed, highly available and secure Apache Kafka service. You can actually use this tagline like a serverless Apache Kafka because it's truly fully managed. Additionally, it is fully compatible with an open source version of Apache Kafka with native integration with AWS services. So you've got supported versions like 2.4, 2.1 up to the oldest possible 1.1.1. Additionally, it is globally available. It wasn't like that during the announcement, so it was announced during the reInvent. And at the start, it was available in like 2-3 regions. So it was a little bit problematic when it comes to the global setup. However, nowadays, it is fully available in 17 AWS regions, and new regions are actually coming. AWS claims that it is the least expensive fully managed Apache Kafka if you will count this per gigabyte. That's pretty interesting because they are actually competing with Confluent and other Kafka providers, and it is actually the cheapest version. However, if you will think about it, Confluent should have more and the best coverage when it comes to the newest version of Kafka, or the best coverage when it comes to the features available in the Kafka. So I think that it will be pretty interesting to see unskewed benchmark when it comes to the price, but that's what they are claiming when it comes to their website. The most interesting part regarding the MSK is that they are having fully managed Kafka upgrades. And this is a new thing that actually many people wanted to have since the release, and this feature wasn't available during the release, and that was actually the biggest culprit of the service. Nowadays, you can fully manage the Kafka upgrades, and you can also seamlessly scale both amount of brokers itself, and also storages. So it's a pretty interesting service. We'll talk about this in a moment regarding the scaling part. I saw that the Flashpoint is here, so hello Flashpoint. I hope you can hear me well. So let's go then. As usually do, the presentation has 3 parts: architecture, when we cover the big high-level overview, building blocks, integrations, and use cases. Part 2 is about operations, when we talk about high availability, scalability, pricing, and security. And last but not least, part 3, when we talk about best practices, how to choose between existing services and how those integrations with the services available on AWS looks like with the Kafka. So let's start with obviously a disclaimer. MSK is partially an open source technology because it's based on the open source version of Apache Kafka, and it is fully compatible with it. However, AWS bits are not open sourced, so in some places there might be a speculation or deduction, especially if you are thinking about integration with Apache Flink or the integration with AWS Lambda that was announced like 1 or 2 months ago on the one of the AWS summits. So those bits are not open sourced, and we are pretty much having just an educated guess how it works until it will be covered by the documentation fully. Let's dive into the architecture. On the highest possible level, when it comes to the website, they are showing already very interesting details. So when you are creating an Apache Kafka cluster, you are actually having virtual machines on Amazon EC2. Those machines are not maintained and hosted in your environment, but they are maintained on the AWS side. And that's a pretty interesting choice because this gives you a similarity to the Amazon MQ, where they have also a VPC, a separate one managed by AWS in their AWS account. And they are actually maintaining and having those services deployed on their side. So it's a very similar service in that sense that you are actually having those clusters deployed under the AWS account, and they are managing those for you. Additionally, they are showing you that it's very easy to build and configure the producers and consumers based on the EC2 instances. And nowadays, you don't have to be constrained just by the EC2 instances. You can use other stuff. We will talk about this in the integration section. But more or less, the cluster creation gives you the insight how the process is organized. So it looks like as follows. On the left side, we've got the information about Amazon MSK VPC, where they have separate subnets, separate VPC, they have Zookeeper inside. So those brokers and Zookeeper nodes are actually an EC2 instances, and those are available inside the subnets managed by AWS. So they are maintaining, patching, and handling the security of everything. And then when the customer comes and provisions a cluster, they connect the customer VPC with the Amazon MSK VPC via Elastic Network interfaces. So we can actually have a connectivity between the subnets and the VPCs via ENIs. If you can remember, we presented exactly the same mechanism on the Amazon MQ side. So it actually works in the exactly the same way. So AWS maintains the active Apache MQ, Apache Active MQ instances in their VPC, and then via ENI we can actually connect the managed service with our VPC and connect the all bits together. So that is very interesting mechanism, and it's pretty much a pattern. I'm using air quotes because it's you can actually harm yourself if you will fiddle with those ENIs. So be careful with modifying those, because for example in Amazon MQ side, with Amazon MQ case, if you will delete or misconfigure the ENI, you need to reach out to the support. There's no other way to reconfigure that. Similarly with Amazon MSK, you have the same situation. If you will fiddle with those ENIs, you will be pretty much screwed. So on the highest possible level, you've got two separate VPCs that are connected via ENIs, and that sounds great. What if you would like to have a connectivity between multiple VPCs? So you've got multiple options. You can provision additional ENIs, or you can actually use the VPC peering, which is also a viable option. So everything happens on the networking layer. Okay, so let's talk about the building blocks. For all those messaging services, we've got very redundant definitions like data producers and data consumers. So the difference between data producers and data consumers from the other services is that on the Amazon MSQ side, when we are emitting records, there's a very interesting mechanism for determining where the data will land, and it's partially related with partition keys and how those keys are maintained and separate the whole events that are going to the cluster. Similarly with the consumer, it's usually an application that has the Kafka SDK that connects to in this case a fully managed AWS service and retrieves data from topics via partitions as they are generated. And depending how you are consuming those data from partitions, you can do it by handling all data, handling projections, or doing real-time analytics on the fly. So Kafka supports all those use cases, and that's pretty much very interesting, useful service to have. The first building block that is different is the topic. And topic can be understood as a category or a feed name which where we are publishing the records. Topics are always multi-subscriber, so it means that you've got multiple consumers for those topics, and they are consuming from different partitions. About partitions we'll talk in a moment, but basically you need to keep in mind that multiple parties are publishing to the topic and multiple parties are consuming from the topic. Topics can be big, can be small, can store data for short or long period of times. There is no limitation regarding retention like in the Kinesis data streams case. So it's already a first distinction between those two services. If you need to store messages for longer than 14 days, which is the limit on the Kinesis data streams case, you should consider MSK, because that will be a much more interesting service for you. Do not confuse topic with a queue. We don't have queues on MSK, and Kafka itself, it does not have any term that is similar or remotely similar to a queue. In a moment, you will see that the partition is basically a transaction log, which is kind of a similar but not exactly the same with the queue, because it affects how consumers are behaving. And when you are creating a topic, you are selecting how many partitions topic should have during the topic creation process. So that's also pretty interesting. You can change those the amount of partitions later, but the whole process of repartitioning the topic is maybe time consuming and may have side effects. Speaking about partitions, each partition is basically an ordered, immutable sequence of records that are continually appended to a structured commit log. So we are actually having a durable log of events. Durable in this sense means that they are persisted to disks and replicated. That's why we need Zookeeper. If you don't know what Apache Zookeeper is, it's basically a coordination system for multi-node clusters that provides you information about ownership and master/follower distinction of those nodes. So you can actually have the leadership election maintained by the Zookeeper and all those metadata that is necessary to handle the distributed systems. And also, thanks to that we have Zookeeper, we can also have replication. And replication for those clusters inside the cluster for multiple brokers is a very important notion, because because thanks to that you will not lose the data, assuming that those brokers are reasonably spread around across, for example, availability zones. We will talk about high availability in a moment. So regarding the partition, it's an ordered sequence of events, and it's sorted from the oldest to the newest data. And partition allows you for independent reading by multiple consumers. And you have also something called a consumer group, which allows you to show an information about how to handle multiple competing consumers, but also you can have multiple different consumers that are storing different, that are processing data on a different manner every single time. So consumers itself can be a different application. So for example, you can have an application that processes data on the real-time basis and counts some aggregations, Windows sums, Windows averages, and so on, like the Apache Flink or something more sophisticated. And then you can write a second application that will be able to replay all those events since the origin and of the Kafka cluster. And when replaying those events, you will be basically doing projections or any kind of batch operations on something like this. And you can do those things independently. That's why we are not having a queue here, but a log. It's a different data structure, and do not confuse those two. Partitions, multiple partitions, allows you to actually have independence between those readers. Additionally, inside the partition, we've got a record, which is should be pretty obvious. It consists of a key, value, and a timestamp. And value is basically a binary blob that is opaque for the whole system. Additionally, records can have also headers. It's a very similar term like the attributes, for example, in SNS or any other messaging services. Speaking about partitions, we need to mention what is the partition key. Usually it's a meaningful identifier like user ID, timestamp, everything, something related with the events itself. It is specified by your data producer when you are putting the data, and those consumers will be informed what kind of, when they will consume from a particular partition, they can also be informed from which partition they are replaying those events based on the partition key association. So this is also a way to separate those messages from the others. And having the high level overview and big picture, here's the distinction between all those terms. So topic is an aggregation of multiple partitions. Inside partitions, we've got data records. Producers can send to a topic, to a different partition, different messages. And as you can see, producer A sends to the partition 1 and 2, and producer B sends only to the partition 3. Additionally, partitions can be consumed by different consumers, like partition 2 is consumed by consumer A and B. And also partitions can be associated in a one-on-one basis to one consumer. So this is how it looks like when it comes to the overview and putting all those terms on a single picture. I hope that it is clear. If not, please let me know in the chat. I will happily explain. Speaking about the use cases, Kafka has multiple different use cases, and virtually anything that needs a durable log of events is applicable, like real-time streaming, data analytics, click streams, messaging, anything that has those event-like log capabilities. Good examples are streaming ETLs, so extract, transform, load use cases, decoupling microservices, transaction processing, event sourcing, which is the very good example of how to handle architectural wise the changes in the application. And you can also have the transaction processing done on Kafka. Messaging is the very good use case, and durable event storage for future analytics. Sometimes Kafka can be treated also as a durable log of all those events that will be someday processed by other applications and replayed since the beginning of time. When it comes to the companies that are using the Amazon MSK in particular, I think the Adobe is a very interesting example because they are using that inside Adobe Experience Manager. They are not mentioned officially on the Amazon MSK site, but they have a reInvent video when they explain why they chosen MSK instead of maintaining their own clusters. So it's very interesting use case and very interesting presentation that shows you why those fully managed solutions are providing much bigger opportunities for such businesses when it comes to the maintenance and when it comes to the releasing the spare capacity when it comes to the feature development, because those people that otherwise need to maintain the Kafka on premise, they can start the feature development that they then can be moved to the different activities instead. Other examples like Compass, Poshmark, Nutmeg, and SecureWorks, also Vonage, ZipRecruiter, and so on and so on. All those companies are actually fulfilling the same use cases that were explained on the previous slide, and they are very good examples how Kafka can be used in various domains and various use cases as well. So if there are any questions, please let me know in the chat, as I said earlier, and we will move to the operations. And operations are pretty interesting from two reasons, because first, we've got a fully managed service. Secondly, Apache Kafka is well known in the community as a complicated service when it comes to the operational part. And I think Amazon MSK has a very interesting, unique selling point. And I think that by introducing fully managed upgrades, they are very close to a sweet spot when it comes to the Kafka operations. So when it comes to high availability, MSK, like any other fully managed service on AWS, uses multi-AZ replication. And it means that data is basically smeared around multiple AZs. And what is interesting is that data transfer between those AZs is included and there's no additional cost. So that's the first very good information for us, because sometimes, not always, but some services has those kinds of pitfalls, and it's great that MSK does not have this kind of obstacle. Of course, if you need to have a regional disaster recovery, you need to handle this on your own. Once again, I recommend the presentation from Adobe, from reInvent, because they explained very well how to do the regional disaster recovery side for Apache Kafka on MSK, because they had to do it, otherwise their business will be affected in case of any regional failure. I know that those may not be so frequent, but still it may be a severe problem for them. Yeah, speaking about scalability, cluster scaling is seamless and even beyond the soft limits that are imposed on the AWS accounts. Currently, you can create 15 brokers per cluster, and if you will cross over 30 brokers per account, you will have the soft limit imposed. But it's fairly easy to raise the quota, and you can actually create more brokers for your accounts. And when it comes to the cluster scaling, you can actually extend and scale up and down without any problems. It's handled automatically by the MSK. The same goes with the exchanging node and changing the sizes. The one problem that you need to be aware of is that there are not so many families and instance types available. So you need to be careful when it comes to the how to handle properly the scaling up and scaling down scenarios. And also, I don't know if that's true still, but some while ago it was a problematic when you are creating a heterogeneous clusters. So you are mixing multiple families inside a cluster. I don't see a point why it should be a problem, but it wasn't possible like 2 or 3 months ago. I think that they fixed that, but don't quote me on that. When it comes to storage scaling, it's very easy and seamless as well. You can do it via both UI and CLI without any problems. So you should be able to scale up and scale down your storage as needed. When it comes to the pricing, the most interesting part is that you are paying basically for what you are using, but you are paying for hourly basis rate. So for storage and for broker instances, additionally you pay data transfer fees, but replication between multiple AZs is handled already and covered by the broker instance hourly rate. So that's great. If you would like to have data out from Kafka outside of the AWS, or for example via VPN, you need to be careful because Kafka is used for significant amount of data, to store significant amount of data, and if you would like to extract that data to your on-premise workers or on-premise applications, you will pay for the outgoing transfer from AWS, and that's a problem because both you are paying for VPNs and also for outgoing transfer. Other than that, when you are processing the data on AWS, you need to be careful about multiple regions. But if you are processing from the same region, you are basically covered and you will not pay additional fees when it comes to data transfer. Additional step and additional point is about security. And when it comes to encryption in transit, it's covered by the SSL TLS between clusters and between cluster nodes and clients. And networking wise, you need to be careful and set up your security groups and your networking properly. As I said, clusters are managed in a dedicated VPC, and the communication between AWS and your VPC is done via ENI. So it's not going over the internet. That's a great thing. However, you need to be careful and diligent when you are setting up the security groups, obviously. And if you would like to connect from a different VPC, so for example, you created Apache Kafka in a particular VPC, but your applications are also working in a different one, you can use like standard methods like VPC peering and similar ones to bridge those different networks together. On the managed side, as I said, communication between cluster nodes, clients, between Zookeeper, everything is handled by the SSL and TLS, and AWS provides any information what they are exactly using there in the documentation. When it comes to encryption at rest, it's handled by the key management service. It supports both encryption with AWS and customer managed keys. So that's a great thing. I think that as we discovered, it was not supported by EventBridge. In this case, this was actually a thing that was very important since the start. Additionally, Kafka MSK is fully compliant with HiPA and PCI DSS and any additional regulations and compliance standards that you need to be aware of that. So if that's your case, if you need to handle those kinds of certifications, reach out to the documentation because it is also covered there. And we are fluently moving to the best practices. So if there's any question, I will happily answer that. I will take a sip. And we can go with the best practices. I don't see any questions on the chat, so I think we can proceed. So let's compare those services that we covered in the past weeks with the MSK. So first things first, MSK versus SNS. This should be pretty easy. SNS is basically a service for notifications for high throughput, multiple channels, maybe sometimes for microservices and then publishing low latency messages. And if you would like to have a filtering via attributes, you are also covered. But I think that the main difference between MSK and SNS is that MSK is durable and it has ability to replay events and have multiple competing consumers. You don't have those things on Amazon SNS. And those two use cases are pretty distinct and they can be easily differentiated. Next one, differences between MSK and SQS. This is a little bit more interesting, but still pretty distinguishable. SQS should be recommended when you need queuing capabilities for your consumers like applications or microservices. When it comes to the MSK, if you don't looking directly into the queuing capabilities, but for ability to replay events and have a durable log, again, MSK should be your thing. Of course, I'm skimming over in both cases the situations when you have an existing Kafka cluster on premises and you would like to migrate this cluster to AWS, because that's an obvious use case what you should use instead. If you have an existing Kafka cluster on premises, probably you don't want to use SQS anyway as a replacement. But if you would like to choose between those two, here's your answer. Amazon MSK versus Amazon MQ. This is a much more interesting one. In both cases, when we are dealing with on-premises, those services can be applicable. MQ will be recommended if you need topics and subscription capabilities, and you have an existing message broker that is an Apache ActiveMQ. In case of MSK, if you have an existing Apache Kafka cluster, that's probably your choice. So in those two cases, you need to be aware what is your technology used on premises and then apply depending on your needs. Additionally, if you need multiple competing consumers, MSK will be a much friendlier approach and much friendlier service to have because it is basically suited for the use cases. When it comes to Amazon MQ, it's a little bit different because those topics and subscriptions are working like in the queuing capabilities. And here is the biggest misconception between those two services. Amazon MSK versus Kinesis data streams. The biggest problem is that the use cases are overlapping and that's the biggest problem. And terms are overlapping too, because here you've got I know that I deliberately used the tilde instead of equal sign because with the tilde, I can actually say that it's remotely similar, and those two terms are similar or kind of overlapping. So on the Amazon MSK side, we talked about topics. On the Kinesis data streams, from the other hand, we've got we've got streams. And topics and streams are similar in a sense that they are grouping something smaller that allows you for having multiple consumers, sharing the throughput, and so on and so on. When it comes to the smaller bits, on Amazon MSK, we've got partitions. On Amazon KDS, we've got shards. And again, those two things are very similar and can be, conceptually, they are representing very similar things. So how to differentiate those two services then? And the simple answer will be that KDS is recommended when you need buffering and durable event log. However, your consumers can deal with shared throughput and you don't need like filtering messages and additional capabilities related to this. If you would like to have more managed service that is cheaper and has shared throughput and you can deal with the shared throughput, KDS is a very good thing. When it comes to the Amazon MSK, this thing will be recommended if you are looking for a persistent and durable log for events for any amount of time, like weeks, months, years, depending on your needs. Additionally, if you need the ability to have a replay of those events, that's another point that should be in favor of MSK. And if you need competing consumers, that's another point in favor of MSK. If you'd like to have raw performance of the virtual machines or bigger features flexibility, KDS is also will be a loser in that battle. So MSK is recommended. So it looks like the MSK should push out the KDS. That's not true anyway. Kinesis Data Streams has great integrations with other services like Kinesis Data Firehose, and they have capabilities to scale much more seamlessly than MSK itself. So I think that the KDS will be more beneficial for the spiky throughput. At least it will be cheaper. And also, if you will use wisely fan-out consumers, you can also have this raw performance by the fraction of costs that you need to spend on the MSK. From the other hand, if you need an ability to replay events that are stored for multiple weeks, months, and years, you don't have such option of KDS because there is a cap on the retention time. So MSK is your only option in this case. So bear that in mind and choose wisely between those two services. And last but not least, differences between MSK and EventBridge. Well, this should be fairly simple as well. EventBridge is recommended when you need messages and routing filtering capabilities, and also integration with the third parties like software as a service companies, AWS services, or you need an unlimited consumer fan-out, and so on and so on. The common ground here is that you don't need buffering and persistence. If you don't need those two things, probably an EventBridge will be a good option. If you need those two things, welcome MSK, because persistent and durable log of events is the thing that managed streaming for Kafka is providing. And also, if you have an existing Kafka cluster, obviously, this is the same case. But I think that this should be fairly obvious. So are there any questions regarding how to use those services and how to differentiate between them? Okay, I don't see any questions on the chat, so let's go to the integrations. Oh, there's one. So did you have any particular use cases that you decided to use MSK for? Yes, but this use case was fairly obvious because we basically have an existing Kafka cluster on premises, and we decided to migrate this cluster to AWS to lower down the operational costs and to offload the operations to the provider. So this was a fairly obvious case. And in this use case, Kafka was used as basically a transaction storage, and there is a couple of applications that are using the data inside Kafka in the real-time manner, and also there are 2 applications that are using the ability to replay all events that are stored, for example, for the past few months, to gather some analytics and batch operations on top of that data. So that would be the use case and answer for your question, Flashpoint. So regarding the integrations, I think that pretty interesting part will be the first 2. So full integration with Amazon Kinesis Data Analytics, which probably many of you never heard of, but it's a fully managed version of Apache Flink. And that's fairly obvious because the Apache Flink is also a standard way to consume Kafka streams, obviously outside of the Kafka streams itself. But if you like to consume the data from the Kafka, Apache Flink will be a nice option. Additionally, there will be an AWS Lambda integration finally, and that's the thing that is missing since the beginning. Unfortunately, it was announced as in progress, so in preparation, and we don't have any ETA, but it was at least announced. I saw the presentation on the AWS Summit like almost 2 months ago, when the person from the Amazon MSK team said that they are finishing the integration and they will release it soon. So hopefully we'll see AWS Lambda integration with Apache Kafka sooner or later. And that will be a game changer because that will actually provide you a very easy way to integrate with the Kafka streams without all those complexities that you are required to use when it comes to the deploying those operators close to the Kafka in a fully serverless way. Obviously, if you have operational knowledge about this, that's pretty easy thing to do. However, if you don't have it, you need to build it and so on and so on. AWS Lambda will ease out the whole integration. Additional interesting integration is KMS. I already mentioned that, so the data encryption at rest. It has MSK has full support for AWS CloudFormation at the moment. Very interesting integration is the integration with Certificate Manager, and allows you for create a private certificate authority and then to create client authentication. And this is very, very interesting integration that should be also an interesting use case when you are dealing with Kafka. If you have multiple clients and you would like to push directly to the Kafka, but still have an authentication and do this authentication properly with the certificates and the private CA, Certificate Manager can help with this. Additionally, the MSK has the ability to export the monitoring from Kafka via Prometheus, via Open Monitoring. So for example, you can export those to the Datadog and to anything that actually accepts the Prometheus exports. Another service is called Lenses.io. I'll get an example in a moment. And basically, thanks to the JMX exporters from the Prometheus, you are able to export those metrics to the external services. Additionally, Mirror Maker, Kafka connectors, and the Confluent Kafka replicator, all those tools are working without any problems with the MSK, as it is basically an open source version of MSK that is sold and provided in a fully managed way on AWS. Speaking about integrations, here is an example from one of the blog posts that is posted on the AWS blog post. Here you can see that they have a Amazon MSK cluster that has 3 brokers in 3 different availability zones, and then they are consuming via consumer groups based on the Amazon EMR with Flink. Nowadays, you can use Kinesis Data Analytics instead of EMR, but also those 2 things are equivalent in the sense that they both provide Apache Flink. Another example when it comes to the integration is the one that I mentioned about open monitoring. So you have ability to export the metrics from the brokers via JMX, and then to fetch those from for example, from the Lenses.io, from Datadog, to monitor your Kafka clusters inside those tools. So it's also a pretty important and pretty interesting integration. Yeah, and that's everything what I prepared for today. So hopefully it was enjoyable for you. And if you have any further questions, I will happily answer them. So next week we are tackling the, if I recall correctly, AWS IoT message broker. And in 2 weeks we talk about AWS AppSync. All those episodes are already created and available in the channel, so you can set reminders. I encourage you to do it because otherwise you need to rely on your on memory and on me reminding you on some channels, hopefully. And other way than that, yeah, that's everything what I prepared. So if there are no questions, I think that that's everything. So yeah, I see Flashpoint that you always remember, so thanks for that. Okay, great. So thank you very much for your attention today, and hopefully see you in a week. Stay safe and stay care. Goodbye.